Today's lesson objective: students use relationships of arcs and chords in a circle to solve problems. So we've got some relationships, some theorems that I need to know first of all. First one, two chords are congruent if and only if their minor arcs are congruent. And so in my picture here, segment AB is congruent to segment CD if and only if arc AB is congruent to arc CD. And this can be in the same circle or it could be in congruent circles. Next property we'll look at. In this figure, SQ is a perpendicular bisector of segment TR. So that means that SQ is a diameter. And if SQ is a diameter, that means the center must lie on SQ. And then because it's a bisector, you notice that PR and PT are congruent to each other. And then what also happens to be true then is that these arcs, TQ and RQ, are also congruent. All right, looking at the next one. EG is a diameter and is perpendicular to FD. So this is the converse, basically, of the one we just talked about. If it's a diameter and it's perpendicular, I know that it's a perpendicular bisector. So FH is congruent to DH, FH and DH. And then I also know the arcs, FG, arc FG is congruent to arc DG. So sometimes they're going to give you that it's a perpendicular bisector and you have to conclude that it's a diameter. Other times they're going to give you that it's a diameter and it's perpendicular and you have to conclude that it's bisecting the segment and the arcs. All right, and so then the last property here. Two chords are congruent if and only if they are equidistant from the center. And so we notice that we have right angle markings here because distance from a point to a line has to be perpendicular. And so in order for the chords to be congruent, so AB is congruent to CD if and only if EF is congruent to EG. And then because the chords are congruent, you know that the arcs are also congruent. So arc AB is congruent to arc CD. So those are congruent, and these are here are congruent. I can't really mark A, B, and C. Okay. So we're going to use this then to solve some problems. So for example 1, in the diagram, circle A is congruent to circle D, and BC is congruent to EF, and the measure of EF is 125. Find the measure of BC. Well, because their chords are congruent and the circles are congruent, I know that the arc measures are also congruent, so the measure of BC is just 125 degrees as well. So here's one for you to figure out on your own. If the measure of TV is 121, what's the measure of arc RS? Okay, so it is 121 degrees also. Alrighty. Now I've got one. I'm going to find the value of x, and I'm going to explain my reasoning. So first of all, I can tell from my figure that ln is a diameter, and they also told me that ln was perpendicular to MP. So that means that ln is a perpendicular bisector, and so these two would be congruent to each other. So 5x minus 6 would have to equal 2x plus 9, and then you just solve for x. So we get that 3x is equal to 15, and so x equals 5. Okay, this next one is for you to figure out on your own. You're going to find the measure of CB, BE, and CE. Pause the video. Okay, so you should have set 4x equal to 80 minus x, and so x is 16. When you plug it in, you find that each of the individual arcs are 64 degrees, so the measure of CE altogether is 128 degrees. All right, example 3, we're going to use the diagram of circle E to find the length of BD. Tell what theorem you use. All right, so I can see in the figure that AC is a diameter. And I can see that AC is perpendicular to BD. Therefore, I know that AC is a perpendicular bisector, which means that DF is congruent to BF. And since I know that DF is 6, so that means BF is also equal to 6. And so the whole thing, BD, would equal 12. All right, in this next example, in the diagram of circle F, A, B, and CD are equal to each other. They both equal 12. And so I want to find EF. So because the chords are congruent, I know that AB and CD must be equidistant from the center. So that means that 7x minus 8 would have to equal 3x. We get that 4x is equal to 8, and so x equals 2. And then plugging it back in, EF is going to equal 3 times 2, or 6 units. All right, so on your own, suppose that FG is congruent to FE, AB is 2x plus 6, and CD is 3x minus 1. Find the measure of AB. Go ahead and pause the video now. Okay, so you should have set 2x plus 6 equal to 3x minus 1. You get x equals 7. AB is equal to 2 times 7 plus 6. Hi, Omar. And so the answer is 20 units. And that concludes the video. Thank you. We're going to do quantities, but if you need things,
I'm just going to start putting my ego together soon.